Okay, hi everyone. So today we're going to continue our study in looking at the SBP paper 2 paper. Okay, and the good news is we finished the first 8 questions, which is in section A. Now we're going to section B and section C lah. Okay, which shouldn't take us too long unless there are many questions that you need to ask. Okay, so if you have done this paper, that's good for you. Okay, then you can just check where where you need to improve your working. But if not, we can always take a, you can always use this session to learn lah. Okay, learn as you go along. Okay, that's also one good way of studying or preparing for an exam. Okay, so you have diagram 9.1 showing the cooling curve of a gas sample. Beginning at 160 degrees Celsius, cooled for 25 minutes. Okay, and it's cooling down lah. Okay, but we always know that whether it is a heating graph, so biasanya we are used to the heating graph, temperature increase. Okay, but even in cooling down, the same principle still applies. Okay, when you are cooling down, okay, the two heats that are involved, okay, it's always the same. It's either specific heat capacity or specific latent heat. Okay, and we know that the specific heat capacity is involved during the temperature change. So if there's a temperature change, this section will be specific heat capacity. This section will be specific latent heat. This one, because there is a change in temperature, ada perubahan suhu, okay, there's specific heat capacity. This is specific latent heat, and this is specific heat capacity again. Okay, and it's very important to note that since this is a cooling graph, okay, the heat is being released. Okay, this is probably the most important thing that you need to remember. Kalau dia adalah meningkat bahkan suhu dia, it is the heat is being absorbed. Okay, but in this case, it is cooling down, so it is being released. Okay, and another thing you want to take note of is that it is in minutes. Okay, if you remember, okay, whenever we do a question that involves heat experiment or heat question lah, okay, usually dia akan melibatkan Q equals to PT also lah, especially if there's power involved. And this T is not in minutes, okay, it's always in seconds. Okay, so now with that, we look at the introduction to the question. Okay, now only lah, okay, we look at this one. Okay, so define the latent heat of fusion. Latent heat of fusion is the amount, okay, of heat required, okay, to change the phase of 1 kg of substance. Okay, tapi ini fusion, okay, fusion is dia melibatkan dari solid, from solid to liquid. Okay, so change of phase of 1 kg of substance from solid to liquid. Okay, change the phase from solid to liquid without a change in temperature. Okay, so this is one of those definitions yang sangat panjang lah. Okay, amount of heat required to change the phase of 1 kg. The important word is actually the 1 kg. Okay, and then of course this one lah. Okay, the change of phase, and because we're talking about fusion, so you want to think about solid to liquid. If you're talking about vaporization, then you're talking about liquid to gas. Okay, you can also say change from liquid to solid, okay, but if you want to say liquid to solid air, that if let's say you want to use liquid to solid, okay, then instead of amount of heat required, amount of heat released, okay, to change the phase from 1 kg of substance from liquid to solid without a change in temperature. Okay, when you talk about latent heat, okay, the word without a change in temperature is the most important thing, because that is what separates the specific heat capacity and specific latent heat. Specific heat capacity is you want to increase by 1 degree Celsius. Specific latent heat, no increase in temperature, change in phase. Okay, so the definition is very important. All right, based on diagram 9.1, explain why the temperature does not change from Q to R, but the temperature changes from R to S. Okay, so we need to talk about, and this is where, this is a very typical heat question lah. Okay, always involving the kinetic theory of matter. Okay, why is there no change in this one, and why is there a change? Why is there a change from R to S? Except that, remember that in this case, the heat is being released. So you cannot say absorb, because the temperature is not going up. The temperature is going down. So you must, when you explain, you still explain the same thing, but you need to think about it in terms of the release of energy. Okay, so from Q to R first. Okay, let's talk about from Q to R lah. Do I have the space? Okay, I'm going to write the 4 points here. Okay, number 1, from Q to R. Okay, Q to R is what? Sorry. This one we assume is gas. This one is liquid. So this is solid lah. Okay, so from Q to R, gas is changing to liquid. Okay, so gas changes phase to liquid. Okay, and it'll be good for you to add what is the name of the process of gas changing to liquid, which is condensation lah. Okay, melalui kondensasi. Gas changes phase to liquid through condensation. Okay, point number 1. Okay, point number 2, always talk about the heat that is released. Okay, again, heat is absorbed. So usually when we talk about heat absorbed, heat is absorbed to, memecahkan ikatan antara molekul lah, to destroy this one. But release is different. Okay, so heat is released. Okay, heat is released to form molecular bonds. Okay, so if you did the question with me when we did, I can't remember which state, is it Malacca maybe? Okay, kan kita cakap pasal absorbing heat bahkan. So it's good that we do this paper because this is a release heat one. So the explanation is almost the same, but it's slightly different. Talk about the process, okay, and then talk about what the heat is used for. Okay, so first point is Q to R, the process is condensation. Liquid gas changes to liquid. Second point, heat is released. What is it released? Why must it be released? So that molecular bonds can form. Ikatan molekul boleh terbentuk. Okay, if it is the other way, if you're absorbing the heat, is to break the molecular bonds, untuk memecahkan ikatan antara molekul. Okay, so think of it in that fashion. So that you remember, oh, if it's absorbed, to break. If it's releases, so that we can bond. Okay. Now, the third one, of course, we have to talk about R to S lah. Okay, why there is a temperature change. Okay, actually, I should add lah. Okay, walaupun it's not necessary, but I should add lah. Okay, heat is released to form molecular bonds, so there is no temperature change. Okay, supaya kamu menjawab soalan. Explain why the temperature does not change. Okay, number 3. Okay, from R to S. Okay, from R to S. This one we know lah. Okay, it is already fully liquid. Okay, so okay, from R to S. Okay, liquid continues to cool down. Okay, dia masih menyejuk. Okay, and then again, talk about why heat is released yang melibatkan temperature change. Okay, so heat is released to what? Kalau kita absorb heat, is to increase the kinetic energy, bahkan. So now it's the opposite. We release the heat to reduce the kinetic energy. To reduce the kinetic energy of the molecules. So the temperature decreases. Okay. So this is a good question now because most of the time we always answer absorb heat, absorb heat, absorb heat. Terus kita ingat. Okay, but it's good for us to also know the opposite lah. If we release heat, basically it's just the opposite of absorb heat. Okay, so if this is a 4-mark question now, always talk about what is the process, what is happening. Okay, if it is a change in phase, then you say change in phase through which process? Condensation. If it is cooling down, if it is heating up, that's the third point lah. Then the second and the fourth point, okay, is you talk about the heat is absorbed or released to do what? Okay, and there's only two functions only of heat. It's either something to do with molecular bonds, either to break or to, so that they can form molecular bonds, or is to increase or decrease the kinetic energy of the molecules. And when that happens, that's why the temperature increases and decreases. Okay, if you do this question often enough, I would say that actually it's quite easy to explain now. Of course, you have to like karang a bit lah. Okay, but if your point is there, you cannot run very far. Okay, yang bikin what you shouldn't be doing is you shouldn't be memorizing it before understanding it. Okay, take some time to understand it see the pattern then once you get it tinggal kau karang saja. Okay, don't worry so much about the right sentence. Make sure the keywords are in your answer. That's how you can get the 4 marks. Okay, question C. Calculate the heat energy required to change 0.5 kg substance at 120 degrees Celsius to liquid at 100 degrees Celsius. Now, if you notice here, they give you two values, which tells you that you need to calculate two things, and you probably will have to add them together. Okay, so let's take a look at this situation. It is 120 degrees Celsius, then change to liquid at 100 degrees Celsius. So originally it's 120 degrees Celsius. Change to here, okay, at 100 degrees Celsius. So we're talking about the amount of heat needed to do this plus this. Okay, the red plus green. Okay, so this one is involving specific latent heat. So specific latent heat there is M times L. Oh, hold on. M times L. Yeah. Okay. Whereas this one specific capacity is MC delta theta. Okay, MC delta theta, and then mass is given to you already. Okay, the C is given to you. The delta theta is important lah. Delta theta here is 120, here is 100. So the delta theta is 20. Okay, so let's calculate this one by one. First, we calculate the red one, the specific latent heat. Okay, so the specific latent heat is Q equals to M times L. M is 0.5. L is given to you, 480,000. 480,000. So no need to think so much lah. Okay, our answer will be 240,000 joules. Okay, the second one is the specific heat capacity. Okay, Q equals to MC delta theta. M is 0.5, C is 1720 given in this question, and delta theta is 20 because it is a change of 20 degrees. Okay, so this will give you the answer of 17,200 joules. Okay, and so finally, what is the final answer? Will be the total energy lah. Okay, so the total energy, okay, is 240,000 plus 17,200. Okay, which will give you 257,200. 257,200 joules. Okay. Now the reason why this is a 4-mark question, and sometimes we have to be smart about this lah. Okay, if it is a 4-mark question, takkan you just want to count one thing, bahkan. Somehow they already give you clue. dia sudah bagi specific heat capacity and specific latent heat. Sure, kamu mesti pakai punya dua-dua. Okay, so I'm kind of emphasizing the heat question because this is one of the questions that we are thinking that will come out in the essay, right? Okay, so but it is a very common question. No? They give you the graph and they ask you to count. Okay, be aware of what you need to count. And usually dia akan melibatkan satu specific latent heat and the other one is specific heat capacity lah. Okay, then you can do it. You of course you need to add them together lah. That's why it's a 4-mark question, kan? Takkanlah kau kira SLH saja kan, terus kau dapat 4 markah. Doesn't make sense. Okay, so let the marks help you to know, okay, how far you need to go. 4 marks is a lot of calculation. Okay, it's not just kira satu benda, okay, habis, begitu. Okay, so that. Okay, state one assumption. Now, this is a very common question. Whenever you do a heat question, the assumption is always one and the same. Okay, no heat loss to the surroundings. Okay, sebab pada tahap kamu, you are not required to consider heat loss lah. Okay, kalau ada heat loss, means kamu kena fikirkan berapa banyak haba yang terbebas ke persekitaran. Okay, but at Form 4, Form 5 level, we are only interested in assuming there's no energy loss, everything akan terpindah menjadi haba yang dibebaskan. So 257,200 joules fully transferred. Okay, not heat loss to know what's around. So this is a very normal assumption that we make. Okay, whenever we do a heat question, if they ask for an assumption, there's almost a 99.9% guarantee that this is the answer. Okay, now you have to remember this. Okay, now come to this very interesting question. So diagram 9.2 shows a floor plan of cluster houses in Malaysia. So a cluster house resembles a semi-detached house which shares the back and the side wall. Okay, which is this back and the side wall. So this one house, one house, one house, one house like that. Okay, the house only has one entrance door and the windows are only at the front and at the side of the house. This house design can minimize the land use. Wow, it's a very tiny house lah. Okay, the bedroom is only like one. Anyway, this is a cluster house lah. So this is what it looks like. Now, table 9 shows 4 models. So let's look at the models, PQRS. And you kind of know that you need to make a choice lah. Okay, so determine the most suitable cluster house model to ensure the inside of the house is not hot. So this is our function. Okay, ini tujuan kita. So let's talk about this. Number of windows. Obviously, we want the number of windows to be higher lah. Okay, 5 or 4. 3 too little already, 2 is definitely out lah. Okay, I'm going to do 5 or 4 because our answer is supposed to be what? Higher number of windows, makan. Okay, why? Okay, so why do we want to have better windows? This one very logic one. Why do you always open the windows to your house? So that better air circulation, makan. Okay, so better air circulation. Okay, aliran udara, aliran udara yang lebih baik. Okay, because when air circulation is better, then you don't need to, you won't feel so hot lah. Okay, better air circulation. Okay, the floor to ceiling distance. So we have 3.2, 2.9, 3.3, and 2.5. Okay, so when you look at this, you kind of think you want the floor to the ceiling distance to be as high as possible lah. Okay, because if it is very low, this one, right? Okay, kalau the roof is very low, then kamu akan rasa macam sangat. In Chinese, we say it's very kok. Okay, so you want to have a high floor to ceiling distance. Yeah, okay, sasak. So again, the reason I would give the exact same reason, better air circulation. Okay, I don't know how many of you live in one-story houses now, but one-story houses are generally known for their very low roofs. So if you go to a house which is one-story and it's quite low, you find that you need more air cons lah, okay, or more windows, okay, because it's quite sasak lah, very kok lah. Okay, now material of the wall. Do we want panel, container, wall panel, why whatever, or concrete block or hollow bricks, okay, or wood? Okay, so this is quite interesting, the fact that they are giving four totally different choices. Okay, but if you know if you know or if you have some experience, okay, looking at houses, which one is hot, which one is cold, you will know that hollow bricks and wood are better lah. Okay, wood is always generally better. Okay, because wood has a high specific heat capacity. Okay, so and also of course hollow bricks lah. Concrete, interestingly, concrete and container wall panel. Container is like metal container, so very low specific capacity because hot very fast. Concrete also, which is actually most of our houses is made of concrete lah, kan? Or at least the blocks lah. Okay, it is very tahan lama, okay, concrete. But the problem is it has a very low specific capacity as well. Okay, so it will get hot very fast. So you want hollow bricks. Hollow, sebab dia ada ruang udara, so that gives better air circulation. But the bricks, bata and wood, have the same common common feature, okay, which is it has a very high specific heat capacity. Because when you have a high specific heat capacity, okay, it will be slower to become hot. It's slower to increase in temperature. Okay, so you want to have materials of high specific heat capacity. And so likewise, the roof, okay, you have two choices, zinc roof or concrete tile. Okay, at this point, you kind of can see where we are going. Okay, we're going to go with the concrete tile for the exact same reason. Okay, high specific heat capacity, low change in temperature. You can also say that concrete is a good heat insulator. Okay, good heat insulator is also a possible answer. Okay, so when you analyze, you see that, okay, R is the best selection. Then you form your answer in the table. Okay, make sure that you know how to write the 9th and the 10th mark. Okay, I have to, how many times I'm going to repeat this again now, because the 10th mark always is an issue with me one. Okay, the 10th mark, make sure you say that the number of windows is high. The floor to the ceiling distance is high. Okay, bigger floor to ceiling distance. The material of the wall is hollow bricks, and then the material of the roof is concrete tile. Okay, although wood okay, actually wood is one of the choices, right? But in your answer, since you already know you're going to choose R, no need to write wood lah. Okay, just write hollow bricks. Okay, so when you write hollow bricks, then after that the reason you write high specific capacity. Okay, and if you see this question, we are using the same reason for both features. The first and the second one is better air circulation. The third and the fourth one is high specific capacity, because high specific capacity means lower increase in temperature, and it's fine. It's okay to repeat the reasons. You don't have to give a different reason every time. But of course, make sure that the reason is berkaitan lah. Don't say, oh, I want hollow bricks for better air circulation. Not really very berkaitan lah. Okay, there's a better reason for hollow bricks because it is higher specific heat capacity. Okay. All right, let's move to the next question. Okay, if there's no question, if you have any questions, just type it there lah. Okay, if not, I'll just go and then go on and on and on, and then after that we'll finish once question 11 is over. Okay, diagram 10.1 shows a low resistivity connecting wire of an oven. Okay, so connecting wire, low resistivity. Okay, let's talk about it. So state the meaning of resistivity. Now, this is different. Resistance, okay, resistance or rintangan lah. Okay, the definition of resistance is the ratio of volume, potential difference Okay, potential difference to current. That's the definition for resistance. But resistivity, okay, resistivity is a measure, okay, satu ukuran, okay, of a conductor's ability to oppose the flow of electric current. Okay, a measure of a conductor's ability to oppose or to resist lah, okay, the flow of electric current. That's why namanya adalah resistance. Okay, kebolehan dia, satu ukuran tentang kebolehan dia untuk melawan arah aliran arus. Sorry, melawan aliran arus. My goodness, my dear. Okay, that is resistivity, kerintangan. Okay, tapi resistance itself is just a ratio, okay, of potential difference to current. Now, explain why low resistivity connecting wire is used. It's only 2 marks. So you just give 2 reasons. Why do we use low resistivity? Okay, number 1, to reduce heat loss. Okay. To reduce heat loss. And then secondly, we use low resistance wires. Always the same reason one. Okay, is to prevent overheating. Okay, this is a pretty standard. This one lah. Okay, so to reduce heat loss or to prevent overheating. Okay, is the usual 2 reasons why we will say for low resistance. High resistance is to produce more heat. Okay, and to produce light lah. Okay, maybe lah. But even low resistance, reduce heat loss, prevent overheating. So explain 2 other factors that can increase, okay, the conductivity of a connecting wire. Now this is a very interesting question. You increase the conductivity by reducing the resistance. So actually this question is asking, how do you reduce the resistance of a wire? Which is perkara yang biasa ditanya. Tapi diorang ubah, explain, 2 other factors that can increase the conductivity. Okay, so actually they're asking the same thing, it's just they tukar dia punya soalan saja. And if you look at it, it says explain 2 other factors, right? Tapi dia 2 markah. Basically just state the 2 other factors. How do you reduce the resistance of a wire? Okay, you use a shorter wire lah. Okay, sebab wire yang pendek, sikit lah dia punya rintangan. Kan, that's normal lah. Another one is use a thicker wire. Okay, sungai yang pendek dan tebal yang luas lah. Okay, will definitely have very little resistance. If you don't want to use the word thicker, you can always use a wire with higher diameter. Okay, kalau kamu mau jawapan kamu yang canggih manggih, okay, you just say wire with a higher diameter, then it will work the same way. Okay, diagram 10/2 shows the power rating. Okay, power rating of this label on the oven. Usually, they may ask what is the power rating, but in case increase cross-sectional area. Yes, you can say increase cross-sectional area of the wire. Totally no problem. It's the same answer as the thickness and also the wire with higher diameter. Okay. Okay, calculate the total electrical energy that is supplied for 90 minutes in kilowatt hour. So the interesting thing is dia sudah bagilah, okay, kilowatt hour. Okay, so the unit is kilowatt hour. So you need to find the energy in kilowatt times with the hour. The unit is given. Okay, so standard formula for energy is E equals to PT. Okay, energy equals to power times time. Same as the heat. Okay, power times time. Now, 90 minutes, okay, since we're counting in hours, we need to change minutes to hours. So 90 minutes, okay, is 1.5 hours. And divide by 60 lah. Okay, so you get 1.5 hours. And what about the power? Power over here is 1,200 watts. But the question is asking for kilowatts. So 1,200 watts change to kilowatt will be 1.2 kilowatt. So the answer will be 1.2 times 1.5. Okay, and you will get 1.8 kilowatt hours. 1.8. Oh yeah, 1.8. So what is the cost of the electrical energy consumed if the oven is used 90 minutes per day for 2 weeks? Okay, for 2 weeks, 90 minutes per day. So, so this is 90 minutes lah. Okay, this is the power, sorry, this is the energy, okay, in 90 minutes per day. 2 weeks will be 14 days, right? Okay, so it will be one total energy, okay, total energy is 1.8 times 14, 14 days because it's 2 weeks. Okay, so we will get, oh, and then after that, sorry, this one I have to calculate. 1.8 times 14, it will be 25.2. 25.2 kilowatt hours, okay, in which one unit, 1 kilowatt hour is 21.8 cents. Okay, so 1 kilowatt hour is 21.8 cents. Then you can calculate 25.2, 25.2 times 21.8. Okay, which will give you about 5. So cost will be 25.2 times 21.8 cents. Okay, which will give you 549.36 cents, which is about 5 ringgit and 49 cent lah. Okay, 5 ringgit and 49 cent. I know this is I'm doing it a very long way lah. Actually, dia just dua baris saja pak. Okay, it will be just 1.8 times 14 times 0.218. Okay, change the 21.8 to ringgit lah. Okay, but I'm just doing it slowly. Count the total energy and then count the cost. Make sure you change the cents to ringgit Malaysia. Okay, and then it'll be done. Okay, so this is pretty standard calculation question which involves energy. Okay, hasn't been asked in quite a while, so it'll be quite interesting to see how this goes. Okay, table 10 shows 4 types of waffle makers. Okay, fine, waffle makers then. Okay, power rating of 240. Yeah. Okay, this is a power rating of 240 and 1000 watts. It's a very high power rating for waffle maker. Okay, but anyway, we have 4 types of waffle makers, JKLM, and we have to consider it in terms of the number of turns, the type of material, the rate of oxidation, and the fuse. Okay, the fuse that you want to wear, the fuse that you want to do this one. Okay, so let's consider the number of turns. Now, again, waffle maker is to produce heat. So you want to have the heat. So if you want to have the heat, you need to have a higher resistance. How do you have higher resistance? Use a longer wire. Use a longer wire means you need to have more number of turns. And the reason for that is to increase resistance. Okay, slash produce more heat. Okay. After a while, you will find that again lah, like I always say lah, you answer long enough. Always the same one answer. Okay, you increase resistance means you produce more heat. And how you do that is you have a longer wire, use a thinner wire, use copper or nichrome. Sorry, use nichrome. Okay, nichrome has, hold on now, let me just check. Yeah, nichrome. Okay, nichrome has high resistance. Okay, the same reason is so if you want to say. Okay, or you can also use another reason if you want, but this is very specific for nichrome only. High resistivity. Okay, but if you are afraid that you cannot remember so many, okay, just keep to the standard ones lah. Increase resistance or produce more heat. Okay, all these things will contribute to this. Okay, rate of oxidation. Oxidation is a chemistry term which talks about rusting. So you want high rate of rusting or low rate of rusting? Obviously, you want low rate of rusting lah, kan? Why would you want something to rust very, very a lot? Kan? So why would you want a low rate of oxidation? So that it does not rust easily. Okay. Notice, and I always see this pattern whenever we talk about exam question, I always notice that they never use the rate of rusting, because then it's very hard for us to give the reason, But the fact that the question is so kind to you, it says the rate of oxidation. Then the reason you can talk about rusting. To us, we understand, oh, oxidation produces rusting. Okay, actually oxidation does a lot of things lah, not just rusting. But we always associate, kita selalu mengaitkan oxidation dengan pengaratan. Because in chemistry that's very heavily emphasized. But what we need to know is that it's very interesting, very rare, sangat jarang lah saya jumpa soalan kan dia akan tulis the rate of rusting. They will say the rate of oxidation, so that you have a good reason to give, which is does not rust easily lah. If let's say the question is, if let's say this table it doesn't say the rate of oxidation, it says the rate of rusting. Wow, then you have to think of another reason. You cannot say the rate of rusting is low so that it does not rust easily. You cannot say that combination. You have to use another combination. The rate of rusting is low so that it will last longer, blah 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 blah. So these are kind of all these little things that I noticed along the way in my years of teaching. Wow. Okay, that I see this pattern emerging lah. Okay, they always say rate of oxidation so that you kind of catch that, oh, okay, oxidation has something to do with rusting, so that it's easy for you to give the reason. Okay, the fuse, this is a very important thing. So how do you know which fuse is on? You cannot just say 3 or 5, you cannot say low or high, okay, because this is one of those cases where it's very specific lah. You need to know how much current is flowing in the waffle maker. And how do you know how much current is flowing in the waffle maker? It's by this. Okay, P equals to V times I. One of the most basic power formulas we know. So when we calculate 1000 watts equals to 240 volts times I, okay, we can count the I will be equal to 4.17 amps. It means the current flowing in this waffle maker is 4.17 amps. Okay, so because of that, you need to use a fuse of 5 amps. So this one is very special. You cannot say higher fuse, lower fuse. Okay, and we find that in electricity, this is the very specific one. When we talk about fuse, you have to give a specific fuse. Okay, which is either 5 or 3, and we are choosing 5 because, okay, the reason is the current flow is 4.17 amps. You don't have to show the calculation, okay? You don't have to show the calculation how you get 4.17, but you should know that it is 4.17. Okay, so again, why I always like to discuss SPP questions because they like to ask all these things that are a little bit unusual, but it's always good for us to know. Okay, if there's a question this year, they ask about the fuse, be specific about the fuse. Don't say higher, lower fuse. Doesn't work. Okay? Because how to give a reason? Okay, because it can be high as in 7. 7 is too high lah. 5 amps is the best, nearest to 4. Okay, so of course, once you have analyzed the table, you see that, oh, okay, K is the best. Again, K. Okay, K is the best because of yada lah. Okay, you get 10. Make sure that you get the 10th mark. If I say more current flow for the justification, cannot. What is the purpose of the fuse? The purpose of the fuse is kalau terlampau banyak arus mengalir, it will putuskan the litar, which is why, and it protects, the fuse is the one that actually protects the waffle maker or the fridge or your TV. Because sometimes, and this has happened to me, sorry, this has happened to my house like twice. Okay, so I don't know if I've told this story before. So one day I was just sitting down, and then suddenly my fan, which was on number 3, my standard my house, the standard, the fan is always number 3 lah. Suddenly my fan at number 3, I was just sitting down there minding my own business. I think I was doing some work lah. My fan at number 3 suddenly began to spin very fast, as if it was on number 5. Then I was like, then I noticed that all the other fans in my house were doing the same thing. And then suddenly my house meletup lah. One of the things in my house meletup lah. Okay, and I realized that, oh, okay, there was what we call a power surge. Okay, and power surges can happen sometimes. Okay, power surges happen, and when power surges happen, suddenly terlalu banyak arus yang mengalir. And then your electrical appliances they get a shock of their lives like, kenapa tiba-tiba banyak ini? So that's what the fuse is for. The fuse is there so that if the fuse is, let's say, 5 amps, anything more than 5 amps yang mengalir di dalam litar itu, the fuse will putus. The fuse will putuskan the litar. It is built to withstand a current until 5 amps only. So if your current flowing is 4.17 amps, you're still okay lah, still can flow on, and you want it to function normally lah. But if there's a sudden power surge when you're using the waffle maker, okay, and power surges can happen for a number of reasons lah. Banyak sebab kenapa power surge boleh berlaku. But when a power surge happens, a lot of current is coming into your house, and anything that is on in your house at that time, okay, kalau dia melebihi, if the current flowing into, let's say, your TV lah, your fridge lah, or your laptop, if the current is flowing too much, the fuse is supposed to do its job, okay, by breaking the circuit so that your laptop lah, your TV lah, your fridge will be protected. You see? And fuse only, of course, fuse only comes in with the 3-pin plug lah. That's why you see a lot of the expensive stuff, well, a lot of the things that we think are expensive lah, always come with a 3-pin plug. Okay, saya belum lagi pernah tengok kan a fridge peti sejuk with a 2-pin plug. Okay, it's very dangerous now because if there's a power surge, that's it now. There goes your fridge. Okay, goodbye. Yeah, MacBook is also 3-pin. 2-pin one is it's a different story altogether. Okay, but yeah, so that's the purpose of the fuse. Okay, the purpose of the fuse is to protect this one by breaking the circuit when there is a power surge, when there's too much current flowing. Sebab bukan kamu yang menjana tenaga, bukan, your electricity comes from SCSB. So one day if the transformer malfunctions, suddenly too much current is flowing in, fuse is there very important. 3 cannot lah, obviously 3 cannot, because your current flowing is 4.17. So the moment 4.17 goes into the 3 amp fuse, dia tidak boleh lah, dia tidak boleh melebihi 3 amps. Dia tidak boleh melebihi 5 amps. That's the idea behind it. Right, let's go to this last question. Well, there are no questions. Okay. I hope you guys are still there. Anyway, okay, so 11.1 and 11.2. Okay, this is a question that came out once a few years back. And ever since then, mesti ada satu negeri kan yang akan pilih soalan ni untuk keluar. Okay, and it's a very interesting, it's a difficult question because it involves calculation and also explanation. Okay, so diagram 11.1 and diagram 11.2 show a Logan sliding down the slide at an angle of theta equal to 30 and 45 degrees. Okay, so with different acceleration. So the frictional force acting on Logan is both the same. The weight of Logan is 250 newtons. Wx is the component that is parallel to the slide. Okay, the resultant force is, okay, so on and so forth, Wx minus the frictional force. Okay, so what is meant by the resultant force? Okay, the resultant force is a single force that represents the sum, I think, yeah, the sum of all forces acting on an object. Okay, the sum of the single force, okay, like for example kiri campur kanan, then lepas tu just one only lah. Okay, the sum of all forces acting on an object. Okay, diagram 11.1, 11.2, compare WX, FX, and the angle theta first. Okay, let's compare WX. If you look at WX, okay, obviously 11.1 is less than 11.2. Okay, WX 11.1 is less than 11.2. Okay, smaller than 11.2 lah. Okay, Fx. Okay, if you look at it, Fx okay, is equals to Wx minus Fg minus the frictional force. The frictional force is both the same. So since the Wx, if the Wx is bigger, then the Fx is also bigger lah. Okay, so you will get the same answer lah for this one. Okay, so for Fx, 11.1 is also less than 11.2. Theta, the angle. Okay, comparing one is 30 and one is 45. So obviously 11.1 is also less than 11.2 lah. Okay, so nothing really much to calculate here. It's just look and consider everything. Okay, then compare. Sorry, relate. Okay, Fx with the angle. So we are relating these two. Okay, so obviously the relation should be the bigger the, which one first? Okay, obviously it's the bigger the angle lah. Okay, the bigger the angle, the bigger the value of fx. Okay, point to note everybody, dia tulis fx dulu baru angle makan. It doesn't mean that the fx must come first in the relationship. Okay, think about it. The angle affects the final, the resultant force. Kan? Macam kamu gelongsor lah. If the gelongsor is very cerun, obviously your force is bigger. You get a bigger acceleration. If your gelongsor is less cerun, then you won't get such a big force. Makan. So be careful with this. Again, I will always say this again and again. Be careful with your relationship. Make sure yang mempengaruhi di depan, yang dipengaruhi di belakang. Okay, what affects what? Okay, jangan main tulis saja sebab question cakap fx dulu, jadi kau pun tulis fx dulu. Tiada. Okay. Alright, second relationship is acceleration and the angle. Also the same thing. Adakah pecutan itu mempengaruhi sudut atau sudut yang mempengaruhi pecutan? Obviously is the sudut bigger, the acceleration will be bigger. This is a very easy question, okay, that you should not be getting wrong because of mistakes like kau salah letak urutan dalam jawapan kamu lah. Okay, so always take some time to think about your answer before you write it. Okay, diagram 11.3 shows a stationary block on a smooth inclined plane when force P is applied horizontally to it. Okay, W is the weight of the block and R is the normal reaction from the inclined plane. Sketch and label the triangle of forces P, W, and R to represent the situation. Now, this is a very, very interesting question because it is 4 marks for one sketch. Okay, no explanation at all. It's just a sketch and label. Okay, it's one of those like, wah, sakit apa yang fikir pun apa yang sama cakap. Tapi, kau kena tahu apa yang kau kena lukis. Okay, weight, okay, weight. So this is the ground, and here is the ground. The weight is always towards the ground. So if this is the center of the object, the weight should be this direction. Okay, jangan juga kamu tulis the weight macam ini. Apa ini? Tiada. Okay, the weight must be always going towards the earth, not at an angle. Okay, it must be always perpendicular to the earth. But the reaction force, okay, the reaction force is always 90 degrees, okay, to the surface that the object is on. Okay, now since this object is stationary, that means it is in equilibrium. Dia berada dalam keseimbangan. And if it is dalam keseimbangan, all you have to do is just draw the triangle where the arrows are following one another. Dia bukan segitiga vektor. Kalau segitiga vektor macam mana? OP plus PQ kan, begini, begini, terus begini kan. This vector. Okay, nothing to do with, they say nothing to do lah. Dia tiada kaitan dengan equilibrium of forces. Kalau equilibrium of forces, we want to draw the triangle so that this one follows one another. Okay, it goes in one circle, one circle, one circle, one circle. Hold on. Yeah, correct. It goes in one circle, one circle, one circle, one circle. Okay, so the best way to look at this would be obviously P like this, and then R like this, and then W. Okay, so this will be P, this will be vector R, this will be vector W. Okay, this will be 90 degrees. The only difficult part about this is where does the angle A go? Okay, where does the angle A go? Now, so the angle A, the angle alpha here, actually should go here lah, between W and R. How do I justify this now? Okay, now if let's say I draw this over here, this is the value of A alpha. Okay, this is the value of the angle of alpha. It's a very long explanation, but I want you to remember this lah. On an inclined plane, the angle yang condong itu adalah sama dengan the angle between the weight and the reaction force, the other side of the reaction force. Okay, always that. So because of that, this one is here. And guys, this is 4 marks. Okay, it's either you get it or you don't get it. Okay, the direction for W correct, 1 mark. The direction for R correct, 1 mark. Okay, make sure that the triangle is in one cheng like that. Okay, 1 mark. And then the angle of A is the last mark. Okay, so the good thing about this question I noticed is that there is no calculation. Okay, I thought that there will be calculation. Then I realized, oh, this is section C. Section C has no calculation. Okay, there is the comparing question. We just need to understand that whatever the shape is, okay, the angle here is always the same as the angle here. Dan bukan di sini, not this one. Okay, so if let's say my triangle is like this, okay, let's say this is the angle of theta, my object is here. Okay, identify the two forces first. Definitely weight is here, and then R is here, right? Okay, the angle of theta is always this one. This is theta over here. Always. Okay, always. Dia macam lumrah alam fakta hidup sudah. Okay, so it's either you accept it or you forget it. Okay, because if you're going to explain this very long, it's going to take me a while and I don't really want to waste that time by explaining this one when we don't really have the time to remember. You don't have to know why the angle there is A. You just have to know that that angle adalah that angle. Okay, and there are only two ways our this one can incline. Hanya ada dua tempat saja di mana kita punya sudut boleh incline, either ke kiri atau ke kanan. And I've explained both. Okay, all you have to know is that the angle of kecondongan ini is always the angle between the weight and the vertical component, not the horizontal component. Okay, the Fy lah. Okay, not this one, bukan yang ini. No, not this one. Okay, this is 90 minus theta. Okay, likewise, this is 90 minus alpha. Okay. All right. Let's go to the last question. Oh, sorry. Okay, so this last question is also very funny. When I saw this question, I thought, wow, okay. Mesti dia suruh kira sudut-sudut kan. In the end, no. Langsung tiada kaitan dengan sudut. Okay. Large number of vehicles using a bridge during peak hour. Okay, this is tidak tahu berapa tahun sudah punya STEM challenge lah. Every year, got 1 year, the STEM challenge is bina satu jambatan lah. So all kinds of weird jambatan keluar lah. Okay. Now, using appropriate physics concepts, suggest a modification of the bridge so that it is safer based on the characteristics of the cable, tower, and pillar. 3 characteristics, 5 you need. Okay, so obviously there's going to be a lot of extra lah. Okay, and it's pretty interesting that they don't give anything about upper characteristic and sedia ada tau. You just have to assume as if you're building an entirely new bridge. okay, on its own. So is this the last paper? Yeah, this is the last page. So I may not have enough space lah, but let's go for it lah. Okay, so the first one will be strong cable lah. Sebab dia minta characteristics. Okay, strong cable. Okay, so the reason for this will be many lah, not easily broken. Okay, or it can also be no, yeah, it can also be withstand a bigger force. Okay, so that's talking about the cable. Okay, if we're going to talk about the tiang, the pillar, no, let's talk about, hold on, let's talk about the tower. Okay, oh sorry, tower. This is the tower, this one. Okay, so can also be strong tower. Okay, or if you don't want to use the strong tower, then you talk about, the tower is made of what lah. Okay, you can talk about the material. Okay, you can talk steel tower. Okay, here also you can also say steel cable. Okay, so the reason will also be the same. Okay, not easily broken, withstand a much bigger force. Okay, actually another one would be possibly does not rust easily. So these two, okay, cable and tower can use the same reason, can use the same set of reasons lah. Okay. Oh, sorry, did I say tower? Hold on, let me see. Pillar. Yeah, pillar. Sorry, hold on. Pillar, cable, tiang. Pillar. Tower, steel. No, correct. The tower should be steel. The pillar should not be steel because the pillar is the bottom here. Okay, it shouldn't be steel. Our experience tells us that pillar is usually made of concrete lah. Okay, concrete pillar. Or you can also say strong pillar lah. Tapi you're kind of like strong cable, strong tower, strong pillar. Sama je different. But yeah lah. I'm actually looking at the marking scheme lah. They're giving the entire thing sama saja. Okay, and also the same reason, except that for concrete you cannot say does not rust easily. Sorry, somebody talking to me? Oh, I heard somebody's. Yes, I heard wrongly. Okay, except that concrete pillar you cannot say does not rust easily lah. Steel pillar, steel tower, steel cable, then you can talk about rust. But if you're going to say strong, then just say not easily broken, can withstand bigger force. You can change the whole thing around lah. Okay, but that's 3 already lah. But we need 5. Okay, a standard one in order to get a 10 marks, we need 5. So we need to think about other things. Okay, now if you can see, our cable here is only 1. It's not a very good cable. This is not a very good bridge lah. Because if your bridge is just hanging on one piece of string, it's not going to be very good lah. Okay, so another possible one would be more number or higher number of cables. Okay, a higher number of cables, then you can, there's many lah. One of course is to withstand bigger force again lah. Okay, the same reason, withstand bigger force, or you can also say to increase equilibrium. Okay, menambah keseimbangan. Okay, that will also be this one lah. Okay, so hold on, 1, 2, 3, 4. Okay, another one would be dia punya ketegangan. Okay, the tension of the cable. Just like when you play badminton racket, right? You don't want when you buy a string for badminton racket, you don't want the string, the tension to be so lembik. Like kalau kau smash pun terus tidak guna kan. Habis kau pukul pun tidak juga dapat smash because the string is so tensionless lah. Okay, so higher tension. or higher cable tension. Not too high, but higher lah, definitely higher. Okay, so that it will, you know, it can be not easily break. Okay. Withstand bigger force. I seem to be saying the same this one lah. Yeah lah, withstand bigger force. Okay, same, like it's like the same reason everywhere lah. You know, sama saja. Okay, I'm looking at the scheme. There are another 3 more answers lah. Okay, I'm gonna give you all. Okay, number 1, the height of pillar is high. Okay, you have a high height of pillar. So why do you want the pillar to be high? So that the water doesn't spill over onto the bridge, or to ensure the safety of the passengers or the people that are using the bridge. Okay, all this pretty apa itu logical lah. Sorry, what's the answer? Oh yeah, avoid water spilling on the bridge. Okay, another 2 more. Sorry, 7. Okay, another one is you want thicker pillars. Okay, you don't want the pillar yang tipis, betul kan, macam pokok getah. You want like big, big pillars lah. Okay, thicker pillars or pillars with higher diameters. Okay, also can. And the reason why we want thicker pillars, this is quite this one lah. Also, you can say withstand bigger force. Also can. Okay, you can increase stability. Okay, another one. I'm going to run away from the withstand bigger force lah. So dari tadi lagi withstand bigger force. Sampai saya bosan sudah dengan itu jawapan. Walaupun dia betul lah, it's true. Okay, if you use thicker pillars, you can withstand bigger force. But I'm kind of afraid now that if you use the same reason too many times lah, macam apa ba ini? Saya tahu lah ada kaitan, tapi jangan malas berfikir lah. Give different reasons. I think it's okay for you to give 2 same reasons, but if all 5 also is the same reason lah, like kalau semua lah adalah withstand bigger force, walaupun dia betul lah, okay, walaupun technically it's true, I just feel that you may be just penalized marks lah, because you're just giving the same reason again and again. Like macam kau tiada jawapan lain lah. Okay. Lastly, of course, you want to have more pillars. If you have more cables, you definitely need to have more pillars. Okay, better support. Better support is an answer. To increase stability also, okay, is and then also to overcome strong waves. Sebab pillar ini dia bersentuhan dengan air lah. Okay, it's touching the water, so you may need it to overcome strong waves. Okay, so as you can see, I'm giving you 8 answers, 8 times 2 lah, 16 answers, but you actually only need 5 lah to get the 10 marks. Okay, but I'm just giving you the entire thing so that you can see, oh, okay, these are the other possible answers that we can use. Okay. All right, and that's it. That's it for our paper 2 for SBP. I will probably do more online classes as we go along, because like I said I won't be seeing you a lot, but I will switch between admits and physics because I'm also teaching admits to ST.